need help logging CEUs. Our next training, we hope to have something at the end of April. We can be found on YouTube and Facebook by looking up Heart of Illinois Water Pollution Control Operators. If anybody knows of any other people that want to be members, please let us know. You can contact Jason after watching videos for certification and the IEPA numbers, or you can email me for membership information. I think that's kind of about it. I'd like to introduce Ram from Flow Technics. He'll introduce our speaker today. Thank you.
All good. Good morning, everyone. My name is Ram, and I'm from Flow Technics. I just wanted to give you a little bit of a heads up on what we are going to tell you, and Jesus is going to tell you, and I'm going to close it by showing you what we told you. So that's about the gist of it, and the basic concept we need to remember is today what we are discussing is a first line of defense in a wastewater treatment plant, and those are screens. And Jesus has about 30 years of experience in screens, and I consider him as a subject matter expert on screens, and I have personally not seen that kind of an experience right now in the field on screens. You can ask all the questions you want with Jesus, and he is the one who can answer every question. If not, then he can definitely go back to his experts to ask all questions. So I'm encouraging every person who is listening to this conversation or this presentation, please ask questions. And that is going to make this presentation much more interesting than what it is. I just don't want to be a one-way conversation. Please go ahead and ask questions. And now I'm going to turn into Jesus Rodriguez from JWC Environmental. Everybody knows Muffin Monster. So we are the Muffin Monster, creators of Muffin Monster, and of course, the first line of defense, screens. Thanks. Jesus, over to you.
Thanks a lot, Ram. This is usually where we get a little applause as the introduction's over. And then, yay, that's right. Then I say a few nice words about Ram, thank him for introducing me. I'm going to start taking him on the road. That was a great introduction, Ram. But seriously, it's really good, to be here with you today. I was telling Ram on the way that it's the first time I've been out of the office in 13 months. I got on a plane yesterday for the first time in 13 months. So it's really good to be here with you in person. I know that we all, miss that intimate contact, and this is how we do business, how we learn, how we do our jobs. So it's great to be here with you today. So as Ram said, my name is Jesus Rodriguez. I'm the business development manager at JWC for Headworks products, and I have been working with Headworks products for over 20 years, not 30. I don't look old enough to have 30 years of experience, so let's not push it so far today. But I will be your host for today's activities. We don't really have a lot of time together today, and this presentation is meant to introduce a lot of information, in a short period of time that hopefully then we'll be able to build on together, as we go into the future. But, we're going to cover a wide range of topics related to Headworks, screening equipment. So that way you'll get an introduction into the different kinds of technologies that are available and how to apply them to your personal situations. So, why do we screen? What are some of the technologies that are available? And we'll do a little bit of optimization and maintenance, at the end. So before we really get started, I want to give you a couple things to think about as we go through the presentation, and hopefully these insights, will help you put into perspective the things that I'm going to talk about. And so when we talk about new wastewater treatment plant projects or wastewater treatment plant upgrades, for example, the capital cost of headworks is between 1% and 5% of a typical budget. But that headworks is really going to do more than between 25 and 50% of your treatment, depending on what the process is that you're using. And that's a lot. And I like to say that headworks screening is a pay me now or pay me later proposition. We can take the time and spend the money to take that trash out up front and do it right, or we can spend the next 20 years chasing the trash through the process, right? So that's really something that's important. It's worth spending the time on. So let's remember to keep these things in mind as we go through the rest of the presentation. Now, when we talk about headworks or wastewater screens, what do we really mean? A screen is simply a barrier with a fixed opening, and it's used to separate one thing from another. In our case, we're separating the liquids from solids, right? So the liquid stuff from the chunky stuff. And your headworks, as Ram said, is the first and really perhaps the most important step in that wastewater treatment process. So great care should be taken when we're designing and selecting our headworks equipment. Now, historically speaking, we've definitely come a long way, baby. From the earliest days of what we consider modern wastewater treatment, when there were no screens, basically the treatment was settling, more settling, some more settling, and then maybe a little disinfection right along the way. But really the takeaway from this slide is to notice that wastewater screening is continuously evolving. And it's continuously evolving to finer and finer openings, right? As processes and treatment processes become more sensitive and equipment becomes more sensitive to trash, then we have to evolve along with it. So much so that today, we have bar screens with smaller than a 1/4 inch opening that are available, even though still a 1/4 inch bar screen is really still considered state of the art today. So what is the nature of the material that's being screened out or removed? We generally consider it to be classified in two categories. That's the organic and inorganic solids, where the organic solids are generally man-made things. Okay, so this is stuff that can be broken down and is usually helpful as a food, for example, for microbes in a biological treatment process. And the inorganic materials are generally man-made things and cannot be broken down. So this is trash. It's not useful. So this is things like your plastics and paper, pop cans, straws, flushable wipes, all kinds of things that we don't want to see in the wastewater treatment plant. So these are all the things that must be removed from the waste stream for clean water and clean biosolids. So why do we screen? Why is it important? And there are three primary reasons why it's important to have good, effective headwork screening. First, effective screening benefits every treatment process. Doesn't matter what kind of treatment process it is. By maintaining operational efficiency and peak performance or peak capacity of your systems. And how do screens do that? Well, every piece of equipment and every process is going to work at the way it's intended to do if the trash is removed. Effective screening protects downstream equipment. This is probably the most obvious or visible advantage, is protecting that downstream equipment. So we're talking about pumps, MBRs, blowers, mixers, any type of rotating equipment that comes into contact with the wastewater benefits from effective screening. So, there are things that we can all see. We all know when a pump is clogged and has to be deragged, for example. So that's a very obvious example. But definitely the sexiest benefit is that effective headworks saves you money. All right? And who doesn't like to save money? So, but how does it do that? Headworks saves you money by reducing the overall treatment cost. Okay? Maintaining high efficiency and maintaining low maintenance costs. If that equipment is working well, we can spend a lot more time doing more productive things than worrying about deragging pumps, for example. So, effective headwork screening directly affects the bottom line. Just by reducing that time that we mentioned a minute ago, that time spent maintaining ragged up equipment, that alone can justify the expense of better screens, for example. But that's not all. Okay, maintaining operational efficiency in aeration basins or digesters, for example, drives down the ultimate cost of treatment. So the cost per gallon of wastewater to treat it goes down if we maintain that operational efficiency. And if you were here, I'd ask, who knows what's the single largest cost line in a wastewater treatment facility? Oh, somebody in the room said it. So it's power consumption, the cost of electricity, right? So anything that can help us to increase the efficiency of rotating equipment, lower the power consumption of pumps, blowers, mixers, all of those things, that should be applauded. And we all like, at least I do, I like to think that everybody sees the benefit of effective screening, but sometimes we do things that indicate otherwise. And one example is the common practice of removing screens from a rehab project, for example, that goes over budget. That's considered good value engineering practice, but it's very short-sighted, in my opinion. So lastly, there's an important income stream that municipalities use around recycled biosolids. So we hear about things like cogeneration, pelletizing, land application, and things like that. So these uses all require the final product to be very clean, right? The dried sludge. Otherwise, it's unusable. So let's keep that in mind too. So here's a quick look at what we mean by the results of poor headwork screening. So especially as it relates to protecting downstream equipment. This is an example of a problem that a lot of you are familiar with. So clogged up pumps, right? Every kind. This is a dirty job. We spend too much time and money doing this, for example. And the problem certainly isn't going away. It's probably getting worse, especially with the advent, of flushable wipes or non-flushable wipes, right? So again, here we see a similar problem. Sitting on the deck these are rags or witch's hair or many other names that we call it, that's been removed, from an aeration basin or an MBR chamber, and if these came out of an MBR chamber, for example, it's a very serious problem, because these rags hanging all over the membranes cause a lot of damage, and that issue can become very expensive in a short period of time. So now that we've seen why it's important to screen, let's look at a few of the more common or most important technologies that are available. So today we'll be looking at bar screens, perforated plate fine screens, band screens, and internally fed drums today. But it's also important to note that there are many other types as well. All right, so spiral screens, step screens, which is a type of bar screen, grab screens and trash racks for very large flows, for example, and flood control, in-channel drum screens, semi-permanent baskets, element types, and there are even more types as well that we just don't have time to talk about. But very quickly, before we go on, I just want to show you two different types of screens that I'm going to mention in passing, but we're not really going to discuss too much about in today's session. But I want you to have a frame of reference so when you see them that you'll know what it is. On the left is a spiral or a screw screen. Many of you are familiar with this type of equipment. Permanent semi-round basket, perforated plate that's cleaned with a spiral with a nylon brush on the edges. And on the right-hand side is a grab screen. This is the Bosker type. So we won't be talking about these in detail today, but I just wanted to show you very quickly so you had a frame of reference to what I mean when I do mention them. So let's go ahead and start with bar screens. And again, there are many types. Okay, so climber screens, which have a single rake arm, multiple rake screens that a lot of you are familiar. So these have multiple rakes that are on a continuous chain, and we are cleaning those bar rack continuously as those chains rotate the equipment. So step screens, so these are thin lamella plates that are alongside each other. Trash racks, so these have flexible rake assemblies, for raw water. They can be quite large, but they're mostly intended for raw water. So you see these in flood control applications, for example. And catenary screens are a very, very early type of multi-rake design. So these are all characterized by slotted openings, right? So one-dimensional screening. That slotted opening is as deep as the water column. And they're also all front loading and front cleaning, which means that they have no opportunity for screening's carryover. And so what I mean by that is all of the trash is captured on the front of those bars and it stays there, right? So that's why it's front cleaning and front loading, no carryover. Now, the bar screens are employed throughout the wastewater treatment system. So you'll see them in collection systems, at pump stations, in the headworks, of course, and they do have industrial applications as well as in septage receiving. Now, as we already saw, why is this a piece of equipment helpful? It's mostly used to protect downstream equipment from large debris. Okay, so this is a coarse screen. When we use it as a primary headwork screen, then typically that bar spacing will be 1/4 inch. And that is actually considered a fine screen today. But where you'll see it most often is with large bar spacing, greater than a 1/4 inch, maybe 1/2 to 2 inches in front of large pumps to protect those pumps from damage. So as we go through on terminology, fine screens are typically today considered a fine screen anything with 1/4 inch opening or smaller. Now this type of equipment does have a lot of benefits as well. It is by far the most common screen that's employed today. In every part of the country, it's the most ubiquitous headwork screen that we have. It's quick and easy to install. It's relatively inexpensive compared to the other technologies that we'll talk about. And it's very versatile in that it can be fit into virtually any application. Most all of these in-channel screens that we'll discuss are able to be delivered in sections. Okay, so that allows us to use low overhead space, etc. Now the downside is that this equipment has very low capture rate efficiency. All the types of bar screens that I mentioned, capture rate efficiency in that 40 to 50% range. Now when I quote you capture rate efficiency numbers, we're talking about everything that comes into a headworks, okay? So now let's look at the next type. We'll talk about the perforated plate fine screen or mesh screens as well. Now there's a lot of different types. Now that spiral and screw screen that I showed you a picture of, that's a perforated plate. It can be considered a fine screen with 1/4 inch perforated plate. There are front loading and through flow fine screens as well. There's the center flow and dual flow screens the dual flow especially are used for raw water intake. Can be very, very large equipment for up to 100 MGD in a single unit. And of course, internally fed drum screens also employ a perforated or mesh screening media. Now, this type of equipment is characterized by high capture rate efficiency. Okay, so whereas the bar screens are low capture rate efficiency in that 40 to 50% range, the different designs of perforated and mesh screens can have capture rate efficiencies from 70 to 90% or more. Okay, and that perforated or square opening allows us to screen in 2 dimensions. So whereas the bar screen is screening in 1 dimension, because we're using perforated plate or mesh, we're screening in 2 dimensions, and this is the reason why that we can get such high capture rate efficiencies. Now, since I've told you about 1-dimensional and 2-dimensional screening, it's going to try to illustrate what we're talking about. All right. So on that left-hand side, you see a bar screen with a 1/4 inch opening. It's a single slot as deep as a water column. Why does it have such low capture rate efficiency? Well, you can imagine that if you're a credit card or a drinking straw or a piece of paper, you can squeeze in between those 2 bars and pass through into the wastewater treatment plant. On the right-hand side, now we're talking about perforated plate. We're screening in those 2 dimensions, okay? So longitudinally and latitudinally. Now, that's much more difficult for that plastic straw or paper or anything else, and certainly not a credit card or a golf ball to get through there, and that's why the capture rate efficiency is inherently so much better. There's also a difference between bypass and carryover. All right? So since the capture rate efficiency is not 100%, then there are things that are going to get through a screen. That is considered screen's bypass, okay? It either circumvents the barrier or passes through the barrier in some way. Carryover is different. All right, so this is trash that is actually captured on the screen, but then reintroduced into the waste stream in some way. All right, so on a bar screen, for example, we carry the trash up on the face of the screen, and then we move it over to the backside because we discharge the screens on the backside. Now, if we don't get all that trash off there effectively, it's going to drop into the waste stream behind the screen and enter the plant. So that's called carryover. And we'll see that sometimes it's important or not important, depending on what the treatment process is. Okay? In a standard biological or aeration treatment, a little bit of trash, maybe not so important. In an MBR or another fancy treatment process, right, a little bit of trash can do a lot of damage. So there are certain equipment that's appropriate for one application and not for another.
Do you have data here in Central Illinois, what type of an equipment in the downstream they have, or just it's all over the place?
We're getting a question here in the room.
Yes, all over the place. On that basis, the frontline defense or Edward screen can be designed, and what is your downstream process capable of carrying can fill?
So here's the.
We're trying to break the monotonous.
What are you saying, that I'm boring you?
No. Yes, if somebody talks, yeah. Was there any questions? I asked those people if there is any questions. Is there any question came up?
Anybody watching on the?
They're watching it in the room.
Let them type it.
I'll find out.
All right, so we're going to try to get some questions from the audience, the live audience, if we can. So let's keep moving. So here's a front-loading continuous belt fine screen. So again, all of the trash is collected on the front of the screen, and then it's carried up the face and discharged on the back side. So this particular type of fine screen does have the potential for carryover. But you'll see this type of equipment employed specifically in headworks, as a sludge screen, in septage receiving, and in a lot of industrial applications as well. Typically not in collection systems, because there you're trying to usually protect pump stations, so you're using coarser screens for that application. But it does have high capture rate efficiency. So here we're in the 70% compared to the bar screen that I told you is in the 50% range. Now, there are considerations because for a screen, higher capture rate efficiency goes hand in hand with higher head loss. Okay, so we'll talk about those performance issues in a different slide. But it is moderately more costly, this type of equipment, than a bar screen, for example. But it has greater benefits, all right? So here you can see on that right-hand side that the open area is quite good, right? You can see right through it. But because we're screening in 2 dimensions, capture rate efficiency is 50% better. The amount of trash is actually more than double that we're going to take out with this type of equipment compared to a bar screen. So that superior performance always comes with a price, right? There's no free lunch. So we talk about that higher head loss, for example. And it is more maintenance intensive because this type of equipment, for example, has a rotating brush that's used as part of the cleaning method to get those panels clean. So we can use always perforated plate on this type of equipment, but down to 2 millimeter, even 1 millimeter. So you'll see 1 or 2 or 3 millimeter openings for very sensitive processes. A typical Headworks fine screen then will have 6 millimeter or 1/4 inch openings. We can do stainless steel or UHMW panels. It is front loading, but different from the bar screen. It is rear discharging. So that's where that possibility for carryover exists, and for that reason, this particular equipment is not recommended in front of an MBR. All right, we'll see why, or what's the difference between this one and a band screen, which is recommended in front of an MBR. And I told you that it does use that brush as part of the cleaning mechanism, and I have an asterisk there because the cleaning brush on this type of equipment is a point of contention, right? There are a lot of operators and owners that brush is a problem. Okay, it does have to be maintained. It has to be replaced periodically, and part of that maintaining the brush means cleaning it, and it is covered in poop. All right, it's a dirty job. Nobody wants to do it. So there is an alternative. Okay, JWC does have a through-flow fine screen without a brush. Okay, so we call it a brushless fine screen. Now, because that brush is doing a lot of cleaning, we have to replace that cleaning with something else. So that something else is more water, right? So we add a second spray bar, we throw more water at it, at higher pressure if possible, but we remove the brush. So this option is not for everyone, right? You have to understand that you're going to be consuming a whole lot more water, but on the other hand, you're getting rid of the brush. So that option does exist. Here we just see some nice installation photos. Similar to the bar screen, the through-flow fine screen is pretty versatile, right? We can make them as narrow as 18 inches, as tall as 50 feet. So they're quite versatile as well.
So what are those windows? Go back to the back screen. Those handle. You see those handles?
On the front?
Yeah, front.
So those are front covers, right? So on the upper right, well, first on the upper left, you see here is the UHMW panels version. And in that upper right is the stainless steel panels version that I told you we can do either. Usually a good question there is, well, Jesus, what's the difference? Well, stainless steel is obviously more robust than the UHMW. So if this is being employed as a primary headwork screen, you can expect sometimes to have large impacts, right? Rocks or engine blocks, dead bodies, things like that. So the UHMW panel is a little bit less robust.
Good annual line, right?
Yes. Or in Illinois, maybe Ohio State fans or something. Who do we dislike in Illinois?
Well, once I think we found a dead body in a sewer in that was 25 years ago. Oh wow, 20 years ago. It's a huge. The MWRD has got 80 inches discharge sewer there. That was a long time ago, I think.
Was it Jimmy Hoffa? So the other difference besides the durability is that the UHMW panels have a little bit higher head loss, a little bit less expensive. They have higher head loss because those panels are thicker, right? We use 9 millimeters thick UHMW. The stainless steel panels are only 2 millimeters thick, so it's easier for the water to pass through. And so those front covers, Ram, you were asking, those are removable. We also have inspection ports on the sides. You can peek in there and see what's going on and do maintenance on chains, etc. all above the deck. So I guess it's a good point to mention that right now. All of these screens are all serviced above the deck. So any greasing points are all located above the deck. So doing that preventative maintenance is all accomplished outside of the channel.
If you're cleaning those screens, do you guys recycle? Like, do you use the effluent water in the plant to supply the pumps to keep the screens clean?
Absolutely. So, so for example, the band screen and the fine screen that we just saw both employ wash water. So that wash water can be reused, does not need to be potable. So we'll use reuse water, plant effluent in the cleaning systems. A lot of times, depending on how clean it is, because sometimes plant effluent is not all equal, then we'll screen it as well. So we'll have some kind of filtration so we don't clog the nozzles for it.
So that filtration needs to be, filter needs to be attended at least once in a month, or depending on how clean it is. That goes back to your scheduling maintenance program.
Gotcha.
Where you can, as long as it's like your car. Any equipment is like your car. As long as you keep on doing a preventive maintenance, the screen will last you for the life of the plant. In general, I have seen these people rebuilding screens after 22 years, and they will rather rebuild the headwork screen than go into an improvement process. Rebuilding a headwork screen is probably 10 or 15 grand, depending on the size of the screen. Improvement is 10 or 15 million dollars. You do the math. So they are actually, as we speak, they're rebuilding a fine screen right now. JWC has a maintenance wing which comes over and rebuilds the entire screen for you within certain amount of time, say 3 days, 4 days. And they're rebuilding right now in Rowell, Indiana, as we speak. And you talk to a maintenance guy, he said, oh my God, I didn't even realize that these things to be done. Oh my God, I wish I could record this thing. So I honestly feel every time these guys come in, you better do all your recording so you can actually check the brushes, check everything. That's an actual hands-on training with your maintenance guy, and that's priceless to me, for a maintenance guy. How many people get that opportunity where a manufacturer is coming in and rebuilding it? You're paying 15, 20 grand. If you want to take a full advantage of it, if I am a head of the department, I'll put a drone or a recording up there, continuous recording. And if I want to stream it on Facebook, so be it.
That's a great point, Ram. That's a really, really good point. So oftentimes when we sell a new Headworks screen, we like to offer the owner a maintenance program. Okay. And it can be as simple as 2 years or 3 years, is where I'm going to come out twice a year and inspect the equipment. And every single time, the biggest part of that is training. Okay, so this is an investment, an insurance policy where we're going to do some continuous training for your operators, right? Twice a year we come out with, hopefully there's nothing to do, but we'll show you how to maintain the brush. So it's interesting, when we were looking at the through-flow fine screen with the rotating brush on the back side, we'll get a call periodically and say, hey, Jesus, that fine screen you showed me is a piece of crap, doesn't work. I'm like, well, what is it? It's like, I don't know. It used to work fine, and now it doesn't anymore. I'm like, okay, we'll come out and take a look at it, right? So like I might be with Ram that day, and we'll be walking up to the Headworks, and we can see that the screen is running, right, from as we're approaching. And I'll say to Ram, I said, do you hear that? And I'm like, no, I don't hear anything. He's like, that's the problem. I say, right?
We talked about these things.
Because when the brush is working and cleaning, it makes a very distinct sound as it's cleaning the panels, right?
Acoustic, that's the word.
So when you don't hear anything, the brush is not doing any work. So we go up there and we say, yeah, look, the brush is rotating, but it's not making contact with the panels. So then we put it back in place, and lo and behold, now the screen works again. It's no longer a piece of crap. So that, so that's just one, and if you have that maintenance program, it's just something that has to be remembered, right? And we have to, maintain that brush once a year at least. We say twice a year, go out and take a look at it, make sure that it's making contact. If it's not, then we adjust it, for example.
Okay, hang on a second. So on YouTube, when Ron is talking, the audience cannot hear him very well.
That's right.
So we're going to put you in the front row, Ron. So if you're going to ask a question, go
You're gonna have to walk around here and get in front of the camera. Oh, see, I didn't even introduce the band screen.
He has to repeat my question.
Yes, I can do that as well. So the band screen, again, is a fine screen turned on its side. All right. So here we're having the liquid, instead of impacting the screen on its face, it goes inside the machine, and then the trash is being collected on the inside. So this type of equipment is recommended in front of an MBR because there is no possibility for screenings carryover. All right, all of the trash is collected on the inside of the machine, so we call that the dirty side of the panel. And the clean side of the panel is on the outside of the machine, and the two never meet. So that's what, because of that, and because of the sealing methods that we use, this equipment has even higher capture rate efficiency than the through-flow fine screen, greater than 85%. All right, so now we're really talking about making some impact. Now, it is a bit more expensive. So if we say that they go in terms of capital expenditure, you go bar screen, through-flow fine screen, band screen. All right. Now, every time that we talk about higher expense or higher capture rate efficiency, remember we're also talking about better performance. And we also see a little bit higher head loss again. Now, while there is the spiral screen or the screw screen which I showed you, that's probably the least expensive. So we'll put that in front of or below the bar screen in terms of capital expense. But it also doesn't have great capture rate efficiency either. It's better than a bar screen because it is using that perforated plate, but it's not as versatile, right? So we're only going to employ the spiral screen in plants less than about 3 MGD. However, you'll remember from the first slide that the vast majority, like I'm talking, it's not even close, of the 70,000 wastewater treatment plants in the United States, more than 90% of them are below 3 MGD, right? So while I told you that the bar screen is the most ubiquitous type or the most popular type, the spiral screw screen is a very close second. So here on the right-hand side, now we can see what we were talking about before. It's easier to see how the water enters that screen, enters the throat of the screen, then makes hard right turns as it hits the back, and then is filtered through those panels on the inside. All right. So this is the highest capture rate efficiency of any of the in-channel screens. All right. All of the screens are fully enclosed to reduce odors, for example. Now, again, similar to the through-flow fine screen, all of this band has individually replaceable panels. All right. Now, the most unique thing about the band screen is that you have the opportunity to have panels which are longer than the channel is wide. So a lot of times, clients will want to get more flow through their plant. Okay, but they will also want to screen it better. Clients are usually on a continuum with regard to screening, okay? 30 years ago, they might not have had a screen at all. And they bought a bar screen with a 1/2-inch opening, and they were super happy with it. Oh my God, this is amazing. We didn't realize how much trash that we could collect. And they had that screen for 15 years, and then suddenly, they weren't happy with that anymore. So they went to a 1/4-inch opening. And now 30 years down the line, as the client progresses on that continuum, his comfortability or his tolerance for trash keeps going down. We got to take out more and more and more until we get to the perforated plate, and then he wants to start putting more. He's like, this is great. He says, can we put more flow through it? Usually the answer is no, because we're limited to the width of the channel. But with a band screen, we can make the panels longer, right? We're not limited to the length of the panel by the width of the screen. Panels can be longer. So in a 4-foot channel, I can get a 6-foot panel, and I've got 2 of them. So I'm adding a lot more open area to that space. And this is your best chance for getting more flow through an existing channel is in a band screen. But remember, it's expensive. It's the most expensive of the in-channel types. So this kind of shows you what I'm talking about. The red lines is where the band screen would be installed, right? So on the top part there, we can see an existing channel. I can make those panels longer, right? But you see that the arrows that show you how the flow goes in, goes out the sides, and then around the back. When we have a new construction, we can recess that channel, we can bump it out a little bit, right? So it's a narrow approach, a bump out for where the screen sits, and then narrow again in the back. So we're not limited by the channel width for the length of our panels. So as I told you, this is recommended in front of MBRs. We can go down to 1 millimeter to 6 millimeter perforations. Also UHMW or stainless steel. No possibility of carryover with this equipment. Very high capture rate efficiency compared to other in-channel screens. Now sometimes I'm asked, well, how does the trash get out of there, right? Because the trash is collected on the inside. Over there on the right-hand side of that picture, you see there's a square opening under the drive system. All right, so that's the trough where that trash is collected. So as the trash is collected on the inside of the band, it's carried to the top of the screen where we wash it, and it falls into that trough. And then that trough brings it out of the machine. So we can either do it in different ways, as a sluice way, or a shaftless conveyor, or even a washer compactor. So we can even put a washer compactor inside of the head of the screen to capture those solids as well. So the last ultrafine or perforated or mesh screen that we're going to discuss today is the internally fed drum. All right. So again, these are employed in primary headworks as very, very good for MBR protection for the same reasons as the band screen, as a sludge screen, septage receiving, in all kind of industrial applications, and also a very wide range of flows. Okay, so the largest internally fed drum screen that we manufacture, for example, can manage 12 to 14 MGD in a single unit. All right, very large drums. There's a 60-inch diameter drum by 12 feet long. So large drum. Definitely by far the highest capture rate efficiency of any of the equipment that we've discussed so far today. 90% or greater. The reason for that is that there's no sealing system involved in a drum screen. Everything that enters a drum has to be screened or come out the other end. There's no place for it to go. So for that reason, the capture rate efficiency is very high, because there's no sealing systems to maintain. Now, it's recommended in front of an MBR as the band screen, but the two are very different. So all rotating equipment, my screen, any of my competitors' screens, doesn't matter. They have certain failure modes. All right, so when a band screen fails, it's usually in the sealing system. There are seals between each panel. There are seals all up and down the side of the screen. We have to seal every inch of that rotating continuous band as deep as the water column. So there are a lot of seals to maintain. So it can be pretty maintenance intensive. So usually if a seal fails, you get trash inside the MBR chamber. That's bad. When a drum screen fails, it gets overwhelmed. So the liquid flow comes out the opposite side, and you get a spill out onto the floor. Very bad also, right? So as a designer, as an operator or a consultant, you have to decide what's preferable. Do I want to risk an overflow? Do I mitigate it by building containment? Or do I want to risk potentially fouling a membrane unless these seals are properly maintained? So we talk about the give and take of that kind of design consideration. So here you go, about between 12 and 14 MGD in a single unit, but they also can get kind of small. We'll make as small as an 18-inch diameter drum. All right. It does require pumped flow, although it's also possible to feed them by gravity. But typically, you'll see these in a pumped flow application, elevated headworks, or in an industrial application. Now, the reason you say, well, that sounds great, much better than a band screen, and it can be. But the capital expenditure, there's a break-even point, right? So very, very large screens, very, very large applications. So you imagine you talk about some of the wastewater treatment plants in the city of Chicago, right? So you got 300 million gallons a day wastewater treatment plant. If we were going to do it with drum screens, let's say 10 average, that's 10 for 100, 200 is 20, 300 is 30 screens. That's untenable. And especially in Chicago, they would have to be inside a building. So the infrastructure becomes too great. So we have to it just becomes cost effective you must use channel screens. So there's kind of a break even, in that perspective. When you get very, very large applications, it has to go in channel. Smaller applications, if it's pump flow especially, drums are the way to go. So super high capture rate efficiency, you can have mesh line drums that are used for thickening sludge, where we're talking about thousandths of an inch. So they're designed for pump flow, fully enclosed screens, again, no carryover, so there's a lot of pluses. And just very quickly, I can show on the way here, talking with Ram about a lot of the industrial applications. So these screens are employed all kinds of applications. So we see screening algae, whole chickens over there, feathers, and all kinds of stuff, fish guts. It's an amazing array of applications for the drums in industrial applications. Now, here quickly, if you hadn't been exposed to drum screens before in the past, exactly how does that operate. The water enters the drum from the left-hand side. It might be difficult to read there, but that influent enters the screen at the red circle number 1, and then it spills out onto the drum over the head box there, and then the effluent, screened effluent drains out the bottom, and the solids that are collected on the drum are augured out to the discharge end down there at the red ball number 6.
How many application between in a wastewater treatment? You can repeat the question. How many application in a wastewater treatment plant do you see with the drum screen versus the standard channel?
So the question was, how often do you see drum screens applied versus channel screens? And really, it's kind of regionally dependent, right? So in areas where there is very flat areas, so like in Florida or Texas, places like that, and deserts that are not mountainous, then you'll see more drum screens, right? Because everything's pumped. Everything has to be pumped because there's no gradient to flow by gravity. So those places you'll see more, higher percentage. But even when in those areas, you still see more channel screens than you do drums. So I think it's just because the consultants are more used to designing in-channel or channels leading into a wastewater treatment plant than they are doing the other way. So I think it's kind of still, I'm not going to say it's emerging technology because it's not. It's just that consultants tend to do what they know. And what they know is to deliver wastewater in open channels to a wastewater treatment plant. So here you see a few installations. All of these are indoors, but they don't have to be. So in warm weather climates, we install internally fed drums outside all the time. Now, a question that I sometimes get is, even though we're talking about headworks today, we've mentioned sludge screening, collection systems, pumping stations. So this is just kind of meant to show where we're applying screening throughout, the wastewater treatment process. So, not just in the headworks, right? So we talked about small scale screening, with those screw screens and auger screens, large headworks with the in-channel screens as well as drums. But then we talked about, pump stations and collection systems. We talked briefly, we mentioned septage receiving stations. We mentioned sludge screening. So when you're going to have cogeneration or pelletizing or things like that, that sludge has to be really clean. So you'll see rescreening sludge. Even at the end of the treatment, so if in front of MBRs, and even at post-treatment, right? So in a lot of industrial applications, you'll see that there is a bit of something that doesn't come out, even after the whole treatment process. These are like little plastic beads or something that still has to be screened. So you have to screen again to get those last bits out. So screens are being employed all over the place. They're kind of like fairies or something. So they're everywhere, you just don't see them, right? So now we've seen why it's important to screen, and we've talked about all the different technologies. And so now, says, all right, well, Jesus, then what's the right screen for me? So, well, it depends on, what your priorities are, right? So every client and every end user has different goals. You have to talk about, all right, well, what are my priorities? What's the driving factor in this decision? So if high capture rate is important to you, then we know we're going to talk about drum screens, band screens, or fine screens. It says if you have very large flows, we might talk about grab screens or band screens or even the through flow perf screens. If you're looking for small flows or very affordable, then spiral screens and multi-rigs. And finally, if footprint, if you don't have a very big footprint, then a vertical screw screen might be, so especially in wet wells and manholes, for example, there's the only thing that could possibly go in there is a vertical screw screen. I guess I need to add that to that second slide, because here I'm talking about vertical screw screens and I didn't introduce you to it, so I'll change that. So it depends on what your priorities are, right? So if you're interested in high capture rate efficiency, we've got to talk about what's the opening size. Where are you on that continuum of screening right now? If you're in a plant that's never had a screen before, then you're going to be super happy with a 1/2-inch bar screen, right? Oh my God, this is amazing, right? But if you've had a 1/4-inch bar screen for 20 years, now you're definitely going perforated plate, right? Because you want better capture rate efficiency. What are the hydraulic considerations? So at your peak flows, are you already reaching near the top of the channel with your 1/4-inch bar screen? If the answer is yes, and you say, no, but Jesus, I need a 1/4-inch perforation. You say, yeah, I want to give it to you, but it has higher head loss. So you're already close to the top of the channel today, you're definitely going to be spilling out. So we have to do something else. You can have it, but we need to build you a bypass, or we need to do something to help you so you can screen it, but in a storm event, you're going to have to bypass. So okay, we can do that. So that's how we go through the design process, right? If capture rate efficiency is important, how important is it? What is the process? What are your control requirements? Is budget important? Are you gonna do existing channels, or are we gonna build a new headworks? What's the peak flow rate? There at the bottom, when you talk about that continuum, right? So as the processes change and as the client's tolerance for trash goes down, then we need to move to finer and finer screening. But that's also can be regulatory, right? So regulations can drive us to finer and finer screening. So what are, when we talk about design considerations, the first one we discussed is what's the screening media? So these are all the things that we've talked about today, right? So we've got way down there on the right-hand side, so we've got vertical bars, and we've got perforated plate, and then kind of in the middle that we haven't talked about too much, we've got wedge wire and wire mesh. So usually you'll see wedge wire and wire mesh on internally fed drums, right? So for different industrial applications, or for really, really fine sludge screening, for example, or thickening. But all of those, drive the capture rate efficiency. When we talk about open area, okay? So when we talk about 1, 2, 3, 6, or 10 millimeter holes, number one, anytime that you have as the open area or the size of the opening goes down, head loss is going to increase. Okay? Now, while your capture rate efficiency goes up, cost and head loss go up as well. Now, as it relates to headworks and wastewater screens, what is head loss? Okay, a lot of folks are familiar with pumps and what's the head loss of a pump and what that means. What does that feel like? So for a screen, what does it mean? All right. So if we think about the flow passing through a screen going from left to right, all right. So we're putting a barrier in that flow as it goes from left to right. You have a water level upstream, the upstream water level. Now as it passes through the screen, then it goes down. And that's the downstream water level. So for a screen, The head loss is simply the difference between the level upstream and the level downstream. Simple as that, okay? Now, that upstream level, when we talk about available capacity or the hydraulic profile, that upstream water level may be limited, okay? The most basic limit is the depth of the channel. We have to keep the water, that upstream water level elevation lower than the top elevation of the channel. Otherwise, it goes out on the floor. We don't want that. But there could be other things, right? There could be an upstream water elevation that's known to cause issues in the collection system, right? So if the pipe that's coming into the headworks is it doesn't matter what size it is, an 18-inch pipe, but we know that when it runs deeper than 12 inches, Mrs. Smith's basement floods. So we don't want that either, right? So if there's upstream limitations, we need to know that. And obviously, are the channels new or existing? Is there a budget, etc.? So that's why I ask, what's really more important? Is the head loss more important, or is that upstream limitation more important? There's a lot of times when consultants or even end users, like any manufacturer will come to the end user and say, hey, yes, we've designed your system, and we want to set the maximum head loss as 2 inches. And I'm like, okay, but you've got 12 feet of freeboard. The channels are really deep. It's not so important that the head loss only be 2 inches in that case. It could be 10 inches and you don't care because you have a lot of hydraulic capacity. So when you have that much capacity, then you can be more selective on what equipment you choose because you have that freedom. Now this is talking about that hydraulic profile. Usually a consultant will develop a hydraulic profile, and it starts, if you consider this as a wastewater treatment plant, he'll start at the outfall, okay? So you see here a water level at the outfall, 121.2 feet. And then as we work our way back to the headworks, it gets higher. Aeration basin's 122, right? And this PST is 125, and the grid chamber is 127. He says, oh, but then there's a pump in there. So actually then you see that from the grid chamber there's 128. The headworks is actually lower, it's like 120, but there's a pump. You see, so now we talk about there's that pipe at elevation 120 that we were talking about. Maybe that 120.5, that's the elevation where Mrs. Smith's basement floods. Right? And we want to stay below that. So now this is where we're getting into the nitty-gritty of a design, right? But that's the kind of information that as a manufacturer I need to know. It says, all right, well, what's the hydraulic profile? What are the limitations? What's the peak flow? What are the elevations that we're talking about? And again, what's more important? Is the head loss really more important? Or is that upstream elevation the most important? For me, I always feel like the upstream elevation is most important. Okay? So if one manufacturer says, no, I can do it with 2 inches of head loss, I'm like, okay. I'm doing it with 2.5 inches, but my upstream water level is actually lower than yours, for example. So what's really more important? The head loss or the upstream level? And to my view, as long as there's no upstream obstruction, that upstream level is always more important than necessarily the ultimate head loss of the equipment. Screens can be controlled in any myriad of ways, okay? So manually, with timers, float switches, single level, differential level, single speed, dual speed with VFDs. So really, when it comes to controls, the sky's the limit. Okay, and this is also kind of a continuum for different clients. No, we don't have fancy SCADA, or some clients have very fancy SCADA. Excuse me. So, honestly, today, the PLCs that we use to run a bar screen are hundreds of times more powerful than the computers that we send men to the moon with, right? It's really overkill. But I never take exception to any controls. A client always tells us what he needs. But honestly, if there is no specification, a smart relay has more than enough computing power to run a bar screen in any number of ways that you want. So you can spend really as much or as little money on controls as you need to. And that's what I was telling you. It says, do you need this level of control? It just gets more complicated, right? And sometimes we'll go to start up equipment and the operators don't want to touch it. They say, no, we're not going to touch it. They say, you set that up. Never going inside that box. Well, then it's too complicated. Okay, it has to be only as complex so that the operators are willing to work on it. If it's too complex to work on, then it's too complex for you. Now, we're getting close to the end of the story. So, earlier I told you that operational efficiency is one of the most important things that fine screening or efficient screening can help you with, okay? So how do I get the most out of my equipment? I want to maximize the capture rate efficiency, all right? Now, I'm going to tell you a secret. Any screen, every screen, doesn't matter what kind it is, has a maximum capture rate efficiency when it's stopped. All right. Oh, sorry. Speak into the microphone. Maximum capture rate efficiency when it's stopped. Lowest capture rate efficiency when it's running. Okay? And it makes sense. It says, what happens when your screen fails, stops running, right? Water keeps coming. The water never stops coming. So the trash builds up on the face of the screen, water level rises. That's 100% capture rate efficiency. Nothing gets by, not even water. It's amazing. But spills out onto the floor, it's bad, EPA comes, we don't want that. So we have to run the screens. But the point is that we only want to run them as little as possible. So we want to maximize the capture rate efficiency while also allowing the water to stay inside the channel. So by implementing VFDs, we can run the screen only as much as we need to, maintain that very high capture rate efficiency, and keep the water inside the channel. Now, this was a problem that I was presented with a long time ago. A client had brand new wastewater treatment plant with they had aeration raceways with mixers, paddle mixers inside of there, and 2 brand new 1/4-inch through flow fine screens like the one on the right. When the plant started up, brand new plant, they were deragging mixers like every week, and they got like 30 mixers. So, well, there's trash in the system, in a couple of weeks, it'll all be gone and it'll work its way out of the system. But it didn't, right? So they called me and said, hey, Zeus, the screens don't work. Screens don't work. We're still deragging mixers every week. He says, okay. We'll go down there and we try to see what we can see what's on the mixers. What's on the mixers is horrifying. It's this witch's hair. It's like those giant rag balls that I showed you before. And it's like, all right, well, this is bad. So we go and stand behind the screen, And you've never seen like 5 guys standing behind a screen staring into the poop flow. It's just like we're just looking. It's just we can't see anything. There's nothing getting past the screen. So all right, well, something's there. So then we finally we built a screen. We went to the Home Depot or whatever. We got some window screens, and we made a basket. Stick the basket behind the screen. And again, there's not what we found. What we captured is it's like I call it applesauce. It is just like goo, and it's got really fine fibers in it, hairs, bits of paper. I mean, it's really fine stuff. But that's once that it gets into the wastewater, it reweaves. It's like transformers, right? They're separated out there, and then when they come through the screen, boom, back together. And that's what they do. It says, okay, so now the only way we employed the VFD method, if we can only run the screen as little as possible, build up that mat, we can capture things that are much smaller than the opening size. So now we employed that method on the fine screen, and sure enough, immediately you could see the goo was coming out on the face of the screen. So I said, all right, this is good. It's working. It's working. So I expected that they would still have to derag some mixers. Yeah, but maybe not once a week. Maybe once a month or every 6 weeks. But the problem went away completely. So I was very pleased with the result, obviously. So I know that this works. And this is how we can get, sometimes I'll tell clients, they want 2 millimeter screening. I said, look, you don't need 2 millimeter screening. Your process doesn't require it. I can get you really good capture rate efficiency with a 6 millimeter screen, but we're going to run it like this, right? So a little bit about maintenance, all right? What are maintenance strategies? There's kind of 3 maintenance strategies that are predominant in the industry. So the first one is run to fail. And that's exactly what it sounds like, okay? We put the equipment in, and we just let it run. We turn the power on, and we walk away. And there are some instances where that is appropriate, right? So a lot of electronic equipment, for example, anything that's permanently sealed units, it's not intended for us to work on it, then there is no maintenance to be done. Maintenance free, right? So in that case, those things are appropriate. And also very like throwaway pumps or lighting systems, for example. Those are all things that we don't, we run to fail. A light bulb, for example. We don't maintain light bulbs. We plug them in, we turn it on. When it goes out, we replace it. That's it. Okay? Now that is not appropriate for your wastewater treatment equipment. Okay? Not even grinders. Okay? So some of our grinders that we have clients that, now I'll take that back. Because there are some applications that are so treacherous and so difficult that that's the only thing they can do. They put grinders in, they don't maintain them, or they're making so much money. It's like a gold mine, right? Making so much money that it's not worth the time for them to maintain the grinder. They just put it in. When it stops, they pull it out and put it in another one. But your wastewater treatment screens, not a good idea. Preventative maintenance is what we recommended, what most of all of you are doing now. So that means that you, on a regular schedule, whether the machine needs it or not, we do these certain things. And that type of regimen is intended to lessen the likelihood of a failure and to extend the life cycle of the asset for its expected life expectancy, right? So that's what the thing is lessen the likelihood of a failure. There's still going to be a failure. You just don't know when. So you can do all of the right maintenance, all of everything that's recommended, and lo and behold, still you come in one day and the damn chain's broken or something's gone wrong, and you say, shit, I've done everything I'm supposed to do, and the thing still failed. But that's just the nature of the beast, because you couldn't predict when it was going to fail. So that's the last strategy, right, is predictive maintenance. What if there was a way, and Ram has a magic box over there in front of him, just like, what if there was a way?
This is a perfect slide. Continuing for the next.
What if there was a way, right, to know when the thing was going to fail? He said. So that requires us to collect a lot of information, a lot of data, right? Because there are guys, like I've gone through, different plants and there's all the noises. Remember, I told you the story about the cleaning brush on the fine screen, right? That's a noise, right? So as soon as I knew that the noise was wrong, so I knew that what was wrong before I even saw it. So a lot of guys know that about their equipment. He says, what does it sound like? What's it supposed to sound like? And they'll come through and they say, oh shit, do you hear that? I'm like, yeah, what's that? He says, that's bad, right? So he knows something's wrong. And he even knows exactly what it is because he's intimate with these machines. So he's a preventative maintenance computer, because he knows by the sounds. So we collect vibration analysis, oil analysis, noise measurements, right? We collect all of this information, amp readings, thermal imagery, and we put it into an algorithm, and it tells us, as this value changes, when it starts to go down, stop the machine, change those bearings, put the machine back online. Because if we let the bearing fail, it costs me $10,000 an hour when this machine's not running. So if I can shut it down for 1 hour, fix the bearing before it fails, and get it back online, that's way better than the machine to fail, has to trip an alarm, call somebody, shit, the bearings are out of stock. Meanwhile, it's 2 or 3 days instead of 2 or 3 hours. Right? So that's the idea. Now, it's hard because you have to collect a lot of information and then you have to process the information. So you can spend a lot of money collecting that kind of information, and at some point it becomes, the law of diminishing returns takes effect, where we're spending so much time and money collecting information that we're not getting any better. So you want to find that sweet spot where we're spending just enough time and money collecting data that all of our equipment is working, and we're not way down there where that preventative maintenance is becoming more expensive than the money that we're saving. So I'll just leave you with that, and then next time we come, and Ram's going to talk to you about that magic box that he's got on his desk over there. So this is one last thing, all right? As a capital equipment, we were talking about equipment failure, right? Now, as a capital equipment manufacturer, I'm here to tell you one thing, that as operators and maintenance people, you've been right all along. It's true. Equipment manufacturers design equipment to fail at the most inopportune times as possible, on nights and weekends, on your daughter's birthday. That's the time that you can be sure that equipment's going to fail. But I'm here to help you. Okay? I can tell you when the next time, or I can tell you at least when to expect a failure by answering this one simple question. All right? Does anybody know when does the national peak flow occur at our wastewater treatment plants? There's one time throughout the year when, as a nation, we have the national peak flow. All right? So that's at the Super Bowl halftime. All right. So we're flushing toilets all over the country at the same time. So that's the one thing I can guarantee you. It says at the halftime of the Super Bowl, it said just turn the lights off, go home, because something's going to go wrong. Now, thank you very much. That's the end of the show for today. Very happy to be here. Thanks for having me, and enjoy the rest of your day.
Any questions?
Any questions?
Let me check.
I'll conclude that thing with that video we're talking
Yep,
about.
sounds good. I don't see any questions.
Ask, if you want to go ahead and ask the questions, and then, of course, I will.
All right. Well, then, if there are no questions online, then Ram's going to come up and close the.
Rob, would you like me to show the video first?
No,
You wanna
let me
talk
come
first?
in, close this thing,
Okay.
give them a takeaways, and then show the video.
Okay. Thank you very much, Jesus.
You're welcome. You're welcome.
When do I start?
You're on right now.
Okay. All right. If anybody doesn't remember anything out of this 1 hour presentation, I would like everybody to remember 2 numbers. 50. 50% is the capture rate for the standard bar screens, 1/4-inch bar screen, am I right? Standard 1/4-inch bar screen, the capture rate is 50%. That is what you got to remember. 90% is the maximum capture rate for any screens manufactured across the board. So that's the maximum capture rate. These are the 2 critical numbers which everybody has to remember. 100% is what the capture rate when the screen completely stops. So the 2 critical number is 50 and 90%. You got to find out where exactly you as a wastewater treatment plant manager you got to be. The second 2 most important words I got it as a takeaway is the head loss and upstream level. And these 4 items, if you take away from this particular presentation, the intent of this presentation will be met because you will be enabled to ask right questions when these design of headworks is done with your consulting engineers. The intent of this particular presentation is to make sure you guys are enabled to ask right questions. Right now, probably you are equipped with asking the right questions, and probably you are not. But this is the intent of this presentation. So I guess that is what I would like to give you as a takeaway. And the third takeaway is the predictive maintenance we were talking about. So Jesus talked about run to fail, preventive maintenance. And third takeaway, which I would like to go over next presentation, which is an asset management. I would like to close this presentation with that video, which Jason is going to show you. Thank you very much. Go ahead, Jason.
I'm here to fix the elevator.
Nothing's wrong with the elevator.
Right.
So who sent you?
New guy.
My analysis of sensor and maintenance data indicates elevator 3 will malfunction in 2 days.
Still need a pass.
I'm here to fix the elevator.
Nothing's wrong with the elevator.
Right.
So who sent you?
New guy.
My analysis of sensor and maintenance data indicates elevator 3 will malfunction in 2 days.
Still need a pass.
I'm here to fix the elevator.
Nothing's wrong with the elevator.
Right.
So who sent you?
New guy.
My
Think
analysis
about
of
it
sensor
and let me know
maintenance
what do you
data
think.
Indicates elevator.
Thank you, guys. Thank you for your time. I really appreciate your time. Dave, I got to take your contact information. I'll leave you some iAlert.
Okay, and I think you got it.
Did I give you iAlert?
I just wanted to thank both of you guys, Ram, Jesus. Thank you very much. This is how us operators learn, is by having companies come down here, and we everybody in the heart of Illinois, operators, wants to thank you guys for taking the time to come down here. So thank you very much, gentlemen.